Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC Ventures. WebRTC Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.ventures. Thanks for joining us live today on YouTube, LinkedIn, and Twitch, and welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. For today's episode, Alberto Gonzalez is joining us today to talk about architecting low latency WebRTC applications. Alberto is our Chief Technical Officer here at WebRTC Ventures. So if any of you watching today have been a client of ours, then you already know him. Alberto provides overall architectural guidance and technical leadership in our team and also works closely with our clients to come up with the best solutions for their video application needs. Thanks for joining me today, Alberto. How are you doing today, my friend?
Thank you, Aaron. As always, a pleasure to be here. And yeah, it's doing well. How are you?
Doing well. Can't complain. We're doing our last episode here of 2022. Looking forward to another exciting year next year in WebRTC live video application development. I think there's a lot of interesting stuff that we've been learning over the last few years. The pandemic, and I need to start. That's going to be my goal for next year. I'm going to try not to mention the pandemic in WebRTC live episodes because hopefully we're kind of past it, but it has affected so much of what we do, the interest in this space, the types of applications people are looking for. I think one of the biggest things that we've seen in the marketplace this year is just general maturing, perhaps, of what people are looking for in a WebRTC application. You know, when you and I were first building applications like this 5-6 years ago, we were building prototypes for startups with ideas, right? Now people are coming to us with applications that they've already built, that they're trying to scale, that they're trying to improve, or when it's a new application, it's ready for kind of big time on launch, right? They're much more concerned about things like scaling and low latency. So I think, looking forward to seeing some of the things that you have to discuss today. I know that they're topics that come up a lot with our clients. And so I think will be really interesting to our viewers today.
Yep. Yeah, I think that's a perfect intro because, scaling has been, one thing that has changed quite a bit. So,
Yeah, absolutely. All right. Well, let's jump right into it. And for those watching live, you can put in questions anytime, whatever platform you're watching this. And after Alberto's presentation, we'll come back and take your questions.
Great. Today I'm going to talk about architecting low latency applications. I will go over first a little bit introduction, just for those that doesn't know much about it. Introduce a bit WebRTC, open source, CPaaS, and the basic architectures of it, and then we will get into the meat of it, more into the scalability optimizations that we have implemented in many projects, especially these last couple of years. So WebRTC, that open framework, finally standardized last year actually, and being used in so really many companies. I mean, this is basically my way to test this is basically search in LinkedIn who is hiring WebRTC developers. And that's how I know that they probably are using WebRTC. So it's not like a 100% accurate list, but at least these companies have used this, or seems they are using WebRTC. And basically it's that protocol to be able to stream in low latencies, so sub-second latencies, being able to send video, audio, and media. It's pretty simple. I'm going over this a little bit fast because probably all the listeners already know, but they are just based on two main APIs, the media stream API and the RTC peer connection API. Yeah, it seems very simple. Like the basics of it still are simple because everything, the complexities are handled thanks to the WebRTC protocol. But then there can be some additional complexities, and that happens when implementing solutions for more than two participants or two users connecting peer-to-peer. And this is here represented like how a group of 8 participants would be able to connect using WebRTC as it is defined without anything else. And obviously that's a bit messy. There are many connections happening. The users would need to upload their videos to the other 7 participants and receive videos of the other 7 participants. So it becomes like 14 streams happening just because 8 participants are in a call. And that is obviously a challenge for the computers or mobile devices we have today. So this evolved to new architectures that were based on media servers. So the idea of the media server is this intermediate device that would help us distribute the traffic. And here at the right, I don't know if you can see it, but it's just basically a representation of the number of client-side connections based on the number of participants. So that would evolve linearly, which is an issue. Like if we have 50 users, that number of connections would increase to like above 100. So that's an issue, and that's why we use media servers, to be able to use less connections and stream less thanks to the media server. So here I'm going to talk about 2 popular ones, and also you might have heard about this in some of our videos online, but it's basically these 2 are the most standardized for WebRTC, are the SFU architecture and the MCU. The SFU is a little bit, I call it like a hybrid approach, where you send your video and that video is distributed to all the participants, but the SFU server is going to just relay or distribute the traffic to the participants. It's not going to do anything with that video stream. And some popular SFU architectures are there at the bottom, are open source, Jitsi, Janus, LiveKit, MediaSoup. And then we have the other type of basic WebRTC architecture, which is the MCU. And that one will mix the videos. So you will send your video, and that video will get mixed with the other participants, and then will be sent back to each participant. So in that case, you can see there is in the image at the right just one strip uplink and one downlink. And those are 4 popular open source frameworks that have MCU capabilities: FreeSwitch, LiveSwitch, Asterisk, and Corriento. So how we go beyond scaling, like basically those servers are a single server, and there is at the end some limit in their horizontal capabilities. So the server can be increased to have 30 cores, 60 cores, but at some point there are limitations, and you need to start scaling horizontally. You need more than one server, and that's what I'm kind of representing here. So what happens if we have thousands of viewers? A single server cannot handle it. And one use case, typical use case, is for large broadcasting applications, where we would have like this kind of cascading architecture, where the publisher or the small group of publishers send the video to a single server, and that is then distributed to the other servers, where thousands of users potentially could be joining. We just would be adding new servers that are going to have many subscribers, but just very few publishers. Another use case, and perhaps a bit more complicated, is the multi-party video conferencing. So again, you can use a single server for it, but at some point, let's imagine we want to have 100 people in the same call, and the server cannot handle that. So in this case, we could use an architecture similar also to this one. There are other ways to do it, but you could use an SFU that basically relates traffic to another SFU where other participants join. In this case, each participant would be connecting to more than one server at once. And those are like the high level ideas on how to do that, how you architect the WebRTC piece. But then how it looks more in real life. So you need to, you're distributing that, but you need to orchestrate that somehow. You need someone to direct the orchestra, direct the users to the right servers, no? So there are a few challenges that here I explain, but one is that you don't want to have a single monolithic application. So you might want to have the application logic and the media server logic in different servers, so we don't have that many dependencies and things are easier to maintain. So in this case, here I'm representing a diagram where it says the wrapper. The wrapper is where you have the application logic, what would say to the media server what to do. And basically at the right of, we have the SFUs, which represent the media server in itself. So how this flow, and this is just a way to do it, would be like first the user or the actor connects to a dispatcher, which is basically like an authentication server that will be distributing the traffic. So we'll be acting as authentication and load balancing, and we'll also handle the scaling of the additional pairs of, here I call them groups. So if we don't have usage, we only have one group. If the user increases, we would need more. And that's one of the challenges that I mentioned here as well, auto-scaling, which means being able to scale as demand increases. So first, I'll authenticate. The dispatcher decides where I need to connect. And then we connect. In this case, the dispatcher says that we need to connect to the group 2. Then when signaling happening between the actor and the wrapper, so basically making sure that we are able to connect to the media server. And then once the signaling is successful, we would be able to send media and receive media from this media server. So this, again, in a very simplistic way, is how you would handle like some horizontal scalability in your WebRTC application. And another last challenge I mentioned here is over provisioning. So you don't need to only scale, but you also want to down scale and make sure you don't have fixed resources that are not being used. And here is just a small example of how you could set up some auto-scaling rules. I won't go over it in detail, but yeah, basically one way to calculate it is based on the number of users, the spike of users you want to handle. So in the orange line, I just show a piece of 5 users per second joining a media server, and the blue one is 2 users per second. So based on that, you can decide how many servers you need to be ready. So when we reach capacity, the new server is available, but we don't have users that are not able to join a room. So there is a little bit of basic math there, but yeah, that's one thing to take into account. And then there are others also in the scalability, related to scalability, which are things that you need to take care of, like having like sticky sessions and data persistence. By sticky sessions, I mean being able to connect to the right media server that connects to the other participants in the WebRTC call. So there are some ways to do that. You can use a cookie to always connect to the same media server, or you could use some type of authentication in advance to redirect to a specific media server. That's how I explained it in the previous slide. So that's one thing to take into account, and the other is data persistence, which is really important. All servers need to be aware of the current situation of the connections. If a server goes down, another server should be able to pick up those sessions, and users use this new server. So that's what I'm representing in this diagram at the right, just a basic implementation of how this could look like in AWS. And we talk about scalability, but there are also optimizations on the architecture side, on this backend. But there are other things that can be optimized more on at the application level. And here I'm explaining a few. One is SBC, which is something that allows us to send different qualities of audio and video. So basically, you could send like HD quality, SD quality, all published to a media server, and based on the state of the clients, of the CPU, of the different parameters that are analyzed in the SFU media server, the SFU could distribute high qualities to some users and lower qualities to others. So if I don't have enough bandwidth for handling HD, I would be receiving lower quality, but maybe some other user would be seeing the HD quality. So that's how SBC works, and that's really recommended in any kind of, mostly in any kind of few to many or kind of broadcasting solutions, because there will always be many users with different qualities, different bandwidth available. Another is audio detection. So also optimizing the application level to just detect audio and send the videos of the main speakers, things like that, can go a long way to have pretty larger applications. And also there is adaptive bitrate based on resolution. So this is something that was explained by the team, the LiveKit team, and actually they're implementing this, which is based on how big is the video component that you have on your website, for example. You can reduce the resolution if that video element is very small, and that also helps the media server. And the last one here, I mentioned Opus Red and DTX, and they are optimizations for audio. In specific, Opus Red, what it does is sending redundant audio. So if there's some missing packet, you will capture it later. So there is less chance of broken audio while on a call. So it's just maybe not an optimization in terms of handling more users, but in terms of having better quality in this case. And yeah, the last the last slide is basically looking at the future of application and media optimization. So there are some things you can already do, and some things that are a little bit more risky to do. At least today, depends on what your use case is. But AV1, of course, video codec is very popular. It's today used for decoding in many places, but encoding with it is still not as popular, and the hardware haven't been updated to use that. So basically, it means that it's very CPU intensive, for example, for some devices to publish AV1. But the benefits of it are clear, and you could have the same bandwidth and have much better quality, or lower bandwidth and better quality than what we have today with BP8 or BP9. Those are more common WebRTC video codecs, at least today, in the wild. And then the same thing for audio. So Opus is what everyone uses for WebRTC today, but Lyra V2 seems to be also a pretty new codec that looks promising, based on the Google open source results that I show here at the right. It looks really good, that lower bit rates achieve almost half of the bit rate achieve the same level of quality or score that Opus. So that means also a reduction of bit rate needed. And then there are other optimizations in the terms of machine learning that can be added in your application as well. Not as much also about for scaling, but more for improving the quality, noise reduction, and packet loss concealment. So some things that actually Google Meet, for example, is doing in their meeting tools, and other similar meeting tools as well. But yeah, it's interesting to keep a look at that, because that can improve a lot your application, and potentially will be even more popular in the future. So yeah, that's it. That's what I wanted to talk about today, Aaron. And yep, now you hold the ring of power. Thank you.
All right, you know I love a good Lord of the Rings reference, so thank you for that, and thank you for excellent presentation, Alberto. Lots of material in there, many of those which could be their own presentation by themselves. So there's definitely a lot to consider in scaling an application. We're going to take a short pause and tell you a little bit about a training program that we have for those of you interested in learning more about WebRTC or possibly joining our team. And when we come back from that short commercial, we'll be taking your questions. So if you're watching this live, whatever tool you're watching in, just drop a comment there. We'll see it, and we'll be happy to take your questions right after this. As a viewer of WebRTC Live, you already know how important WebRTC development is to the modern web. Now it's time for you to grow your career by learning to build live video applications and joining our team at WebRTC Ventures. Go to WebRTC.ventures and apply to join the next cohort of our WebRTC training program. You'll have free access to advanced courses, mentorship from our team, and those who are accepted into the second month will receive a paid development contract and join our team of WebRTC development experts. Go to WebRTC.ventures now and earn your place in our team of video development experts. All right. Thanks, Alberto. Again, thanks to those of you watching, and check that out, that training program at WebRTC Ventures if you're interested in possibly joining our team, and a lot of other great information about WebRTC there as well. So let's go to a few questions. I want to start with one, Alberto. Most of WebRTC application development that we do, that most people do, is it's cloud-based, right? The servers are all entirely in the cloud, as well as obviously the WebRTC itself being browser or mobile-based. But sometimes people do need an on-premise media server solution. So what are the differences when scaling RTC apps on-premise versus the cloud?
Yeah, that's a good question, Aaron. You first might ask what exactly means to scale on-premise, because yeah, basically you might think, well, it's hardware, so you just need to install more hardware, not for that. But actually, there is an additional thing to that. No, like it's not just adding hardware. Once you have that hardware, there are tools that you can use, like Kubernetes, to orchestrate that, and that allows you to decide how your services run. So yeah, you have a fixed hardware, it's on premise, and if you want more, you need to bring more hardware and install it. But you can decide how that hardware moves around. Like if today we need these resources allocated for this specific media server, but tomorrow we are using something else and this media server can be reduced. So basically you have a lot of adaptability there, and you are able to move around, and that's really helpful because not all the time you need a fixed resource all the time, so that's one very big difference versus how it's in the cloud. So in the cloud, it's simpler first, so you don't need to use Kubernetes or anything like that. You just can leverage what cloud providers give for auto scaling, and it's just easier, and in general also you can build that without much knowledge on DevOps, basically, and so that would be the main difference.
Yeah, that makes sense. I mean, generally speaking, when you're using a cloud provider, kind of leaning into those auto scaling tools that they have, and obviously it's one of the benefits of using a cloud provider versus on premises, that some things are easier. Right.
Of course, that has a cost, no, but
right.
that like everything.
Exactly. All right. So getting some comments. Thanking you for an excellent presentation. Certainly agree. The question here from Alfred, who would like to know, what would you recommend for implementing WebRTC broadcasting, open source and commercial options?
Without knowing the use case, really is very hard to answer like the question saying like this is the one, because there are so many like great tools and frameworks out there. I know I would say, like, based on your stack, think about what technologies you like. That's one to decide that, but also test them out a little bit. Like I know like very well maintained ones right now are like the four I mentioned in the presentation, like Jitsi, Pion, LiveKit, Janus. So those are some that are actually also used by large companies out there. So they are proven to work. So I think those probably would be good options. But all of them, like today, all open source media servers are ready to broadcast, I think, to have broadcasting options. So.
Excellent. And thank you, Alfred, for the excellent question. Alberto, for those who want to consider using multiple CPaaSs or open source media servers at the same time, this comes up sometimes where maybe for automatic failover reasons or backup reasons, if a particular provider goes down, I mean, when you're hosting on a cloud provider, you think about doing things like spreading your resources across different regions and things like that for failover reasons. This is like a more complicated version of that, right? Where maybe you're trying to not just scale your media servers across regions, but even across different providers. What would you recommend for that type of request?
Yeah, I think that's a great idea. I think like I would, especially if you already have some mature project, I think makes sense to test other things out, especially if you are not happy with it or you think there is room for improvement. Mm-hmm. I think one way to do that, and I think that can be helpful, it's good to have first a mental diagram of how each of these providers work. For example, as an example, I know like Vonage, Daily, Twilio, they work in a pretty similar way. Like you create a token, you obtain this token that creates something like session, somehow like that, and then you join and you have events. So that's kind of pretty standardized. that's the first thing. Make sure there isn't things that are completely different there. And once you have that, probably you want to code, like have a wrapper, some type of code that would translate to the different providers. So intermediary piece of code that will handle that. No, like I don't want to be calling, like if I mute myself, for example, and I want to call that mute, I don't want to call different type of mute every time depending on the provider. I
Right.
just want to say I want to mute, and then there will be this intermediate piece that we would need to write that would translate it to the provider we are using. So we will have this wrapper, and I think that's probably the recommended approach to do that. Like have some, of course, that's work. That's not something like you will do in a few weeks, especially if you want to have more than two, then even more. But it's something that is, I think, pretty good idea. Some people is doing that also, not only with CPaaS, but combining open source and CPaaS as well. So yep.
Mm-hmm. Yeah, absolutely. Yeah, it's not entirely unusual for us to help a client move from one solution to another, right? They may, and it could kind of go in almost any direction you imagine. They start with a particular CPaaS, and then they want to move to open source. So they start with a particular open source project, they want to move to another one, or they want to move to a particular CPaaS or change CPaaSs, et cetera. So yeah, building in that intermediate layer there is smart. And presumably, if you know that that's a possibility for your business in the long term, that may be something you want to do up front, right? When you're first building the WebRTC application. What other types of things do people struggle with in your experience when they're building their first WebRTC application?
Yeah, so I think it depends how technical they are. No, there are many cases like there can be like the person that is not familiar at all with WebRTC, or they are starting to learn a bit, and the first surprise usually is, oh, but it wasn't supposed to be peer-to-peer. Why you need this intermediate server for everything? I think that's for maybe the people that kind of learn about it recently, but others that maybe already understand that they already set up the media server. Then the challenge becomes, okay, I have this demo working, I want this to scale. I want this to handle, 100 users in a video room, and it seems it's not working,
Yeah.
And it's usually, scalability is a problem, and also testing that is working, I think, is also another one. Testing that you can handle that amount is also sometimes an issue.
Yeah.
Another one that I think can be pretty common is also how to handle all these edge cases of like when you use WebRTC of the camera, or this kind of flow is not very common in the web usually. But yeah, device access, guiding the user, the non-experienced users with audio preview, video previews, things like that.
Right.
Handling reconnections when you change Wi-Fi. We are not used to doing that with websites because that really doesn't matter much. But in a video call that is live, it's going to be an issue.
Yeah.
Yeah.
What's the hardest use case to scale?
Yeah. So that's probably the video room. Scaling a large video room is complex because and you can see that from when you check the different CPaaS, you will see that their limitations for video room are much lower than for broadcasting. So that kind of tells you that it's probably harder. And yeah, it's because video rooms, usually if you have, imagine 100 participants, that means a lot of connections because it's 100 that you are sending your video, but also it's being distributed to other 99 users. So the server needs to handle much more, and this becomes you need to have more than one server, and that is an additional logic you need to build on top, like to have users connecting to the same to different servers at the same time to be able to have these large calls, and the additional logic also to not display all the users, because our computers today cannot handle 100 videos. So you need to just display some and limit that. So
yeah, I think handling the UX around that of how many of those people you display at once is always an interesting problem, and varies with the use case that you're applying it to.
Yep.
We have a comment here from Salim I think in response to my earlier question of, what do people asking you, what do people struggle with when building their first WebRTC application? And Salim says maybe they're stuck with firewall problems. That's very, very common in building your first application, right? I mean, we were as we do this time of year, looking back on what are the most popular videos that we've made, the most popular content we've made on WebRTC Ventures and on our YouTube channel. And year in and year out, the most popular videos are always about stun and turn and connectivity, and basically, it's still some of the basics in a way of WebRTC, right? How do you establish that call even before you scale it? If somebody's behind a firewall, how do you connect them?
Yeah. Recently, actually, we're working on a project, and also, we were struggling, and the issue was related to that as well. So many times, the ice gathering process, and also how that's done in different browsers, in different devices, and all the different networks. So that's still, I think, a little bit of a challenge sometimes for some edge cases.
Yeah, absolutely. And while it may not necessarily be a challenge of scaling itself, it's a it's a connectivity challenge regardless of scale. The more you scale, the more you start to see these problems with your users, and if you haven't solved them properly, they'll come up more, obviously. So, all right. Well, let's close with. I'm going to ask you to. It's the end of the year. It's a time of year that people like to make gift lists. They make sort of a wish list, or they're thinking about what they want to do the next year. So, Alberto, I'm going to give you a chance to speak to the universe here and speak it into existence. What is a use case or something that you would be really excited to work on in 2023? Something you'd love to see a company approach us to work on. So what's a cool WebRTC project you'd like to be building?
I mean, in general, I like, in the past, we worked with in telepresence projects. So I don't know if you might remember, like we built some remote controlling robots. I think that's a pretty cool topic. Something combining that with some maybe more popular terms today, like augmented reality, or AI. I think would be cool. I think it pairs very well, actually, WebRTC and augmented reality for things like training or education purposes. Like being able to have teaching something that you really need to see. Like if you're a pilot and you need to simulate the environment with a VR headset, how you explain to a student or a doctor, how you explain how you do some operation without testing with a patient. Like better to use maybe some VR or AR headset. So I think that's a pretty cool topic. I think obviously it's not yet the most popular thing, but I think we start to see it more. Like I know there have been like at least a couple of recent leads coming in related to that in our team, and so I know, like, we didn't hear about it like 2 years ago, and now it's something that there will be from time to time someone talking about, I want to build a WebRTC AR application or VR application. So I think that would be pretty nice.
Yeah, I totally agree. Completely agree. Yeah, I got some ideas. But yeah, I think it would be really interesting to work on some things like that next year. All right. Well, Alberto, thank you again for joining us today. Appreciate all the work that you do in our team and with our clients, of course. And thanks for sharing your wisdom. For anyone who wants to follow up with Alberto or learn more, you can contact us by going to WebRTC Ventures. Thanks for your time, Alberto.
Thank you. And yeah, thank you everyone for watching. See you.
All right. As always, this video will be available on WebRTC Ventures on our YouTube channel, as well as on our blog at WebRTC.ventures. And to find out more about our upcoming episodes, just follow WebRTC Ventures on Twitch, LinkedIn, YouTube. Join our email list at WebRTC Ventures. Thanks, everyone, for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.